Okay, good morning, guys. This is Physiology. Today's April 22nd, and we're going to continue our lesson on the endocrine system. So, for those of you just joining me, I was sharing the rest of the modules that are due for this section that we're on, and I'm going to just briefly share with you what I covered with everyone. Um, so, right now we are on the endocrine system, chapter 7. And we've already completed the first two folders. The first one is just notes. The second one are these two assignments that you already did, reading and watching. Most of you in this group already did. And then there's a formative assessment. And the formative assessment is literally just a free response quiz, very similar to the ones we do in class. But like I was telling people earlier, please disregard the date of April 24th. I just put that in there because the computer needs a due date. But because I'm making these modules self-paced, if you feel ready, you can do this quiz now. You don't have to wait for me, actually. You can just message me. I'll unlock it for you, but I won't grade any of them till I have all of them done, okay? And I'm not letting you see your answers on these anymore just because I'm letting you do them at your own pace. So because I know that if one person does it, then the answers can be shared. So I'm not going to give anyone any answers until every single quiz is done, but you can start it now and get it over with. The other assignment you have here is the discussion board assignment, which I just finished talking about with the group. So please go ahead and read that. Disregard the due date. You can finish it today if you want. You can do all these today if you wanted to, but I'm just putting those due days just so that you have a time frame. But I try to space all of them out so they're not all due at once. And then the last assignment, like I was telling everyone, is we're going to do a summative assessment, meaning this is how I'm going to see that you understood the whole endocrine system, as a video or digital project presentation that you're going to work on in groups. And it's going to be very similar to how you guys used to do my D&C frames in your notebooks, but because there are no notebooks anymore, you can do this either as a brief 5 to 10 minute video or a 10 to 15 slide presentation. And as always, because we're on the endocrine system, I like to wrap up with going over like the pathologies or like what's wrong with them, what causes issues, right? Very similar to the case study that we read at the beginning of this chapter. Any questions for me so far about the remainder of the module? What questions do you have, guys? What questions do you guys have about the modules? Thumbs up if you're okay and you understand the module assignments. Okay. And Brianna, are you good? I didn't see a thumbs up. Okay. Okay. So again, I'll expect a message from you guys if you are ready to do the rest of these assignments, especially the one that requires an unlock, which is the quiz. You have to message me. I'm not going to turn that. I'm not going to turn it on just because I assume everyone's going to do it today. So you have to message me. But the others are self-paced, so you can do them whenever you want. Okay. Um, but to conclude, we're going to get into a Zoom group now. And what I'm going to do is I'm going to first show you a video to refresh your memories about a really, really important point that we've been covering in the endocrine system. And it was something that was mentioned in the crash course video, and that's the feedback loops, especially a negative feedback loop, which is covered in chapter 7. So before I begin showing you this quick little video of negative feedback loops, can anyone tell me what they remember about negative feedback loops?
Isn't it more often to occur in the body?
Yes, correct. Yeah, they are the more common of the two loops. So there's positive and there's negative. And yes, negative are the very common ones, Anna. But like, what are they? How does it work? What's an example of one? There was one in the crash course video that mostly everyone here turned into me already. So if you have your crash course answers in front of you, you can just look at your crash course. I'm not tricking you. So what are negative feedback loops? I'll wait because I'm not going to move on until I see that people are engaged and looking at their notes and know what I'm talking about. So what is a negative feedback loop?
Is one the female menstrual cycle?
What about it?
Um, hold up. Let me look at my notes. Mm, mm, Hold up. I can't open my notes.
It's okay. While Angel's looking for that, anyone else want to jump in? What are negative feedback loops? Or what was the example of negative feedback loops in that crash course video, since you all turned in the crash course watching assignment?
Was it the insulin
Yes,
example?
exactly, Daisy. Exactly. Can you tell us a little bit about that example to refresh everyone's memory?
Okay, so like the example was with the pie, so that if you eat it, like your blood glucose level is gonna go up, and so when that happens, the pancreas is gonna release like two different hormones,
Hmm.
so like insulin, and so like the insulin is gonna decrease the blood sugar,
Exactly.
and the other one was glucagon, which helps decrease the storage of sugar in the cells, and the insulin increased the rate at which the cells stored sugar.
Exactly. Exactly, Daisy. Couldn't have said it better myself. And so please, everyone, have that worksheet out that Daisy's referring to. It's the crash course video that, like I said, most of you already submitted. Again, that's not like a test. That was just like a quick little check-in. But what I want to do is show you a quick little video now. It's about 2 minutes to refresh your memory as to what feedback loops are. And like Anna said, there's two, but the negative feedback loop, which is exactly what Daisy described for you in the case of insulin, is the one that we really need to talk about, because this is generally how hormones are released in the body. Okay, so we're going to watch a quick little video that I'm going to share with you now. And it is a YouTube video. Where did I put it? All right, here we go. Can you guys see my screen?
Yes.
Okay, so here
Yeah.
we go. Okay, here we go. It's a short little video, and there's subtitles on the bottom. Okay.
Beautiful example of something called negative feedback. Before we define it, let us show you this example. Say you're in an environment that is very hot, like being outside in the Texas summer heat. That's typically hot. Thanks to nerves which can act as sensors, the brain notices this. It will send signals to counteract this variable. Sweat glands do what they do best, sweat. Heat is lost as that sweat evaporates off your skin. You may have some redness too. That's because your blood vessels are getting wider, dilating, in order to help get rid of that heat. The result, whether you realize it or not, helps you lower your body temperature. But wait, what if you go inside now and the AC is blasting? You'll stop sweating. You may even shiver. The muscle contractions of shivering can generate heat. And those blood vessels will now decrease in diameter size, constrict, to help you conserve the heat because that makes it harder for the heat to escape. Your body temperature can increase then. This is negative feedback. So, a simplified definition, negative feedback is when some variable triggers a counteracting response in order to come back to some set point. If we consider that this whole thing is actually a negative feedback loop, we can see that the negative feedback brings the body back to the set point, which in this case is a stable temperature, keeping homeostasis. Negative
Okay, so does that sound pretty much like what Daisy described? Can you tell us how so, Myrtle, since you gave us a thumbs up? How does that sound like what Daisy described? or anyone, how does what Daisy described sound similar to what we just saw in that video? Anyone?
It said that it's when a variable triggers a counteract.
Okay, and so
Mm.
in Daisy's example about insulin, what would that variable be that's counteracting some effect?
The pie?
Okay, and what was the pie doing?
It raised the sugar levels.
Good, 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 good. All right, cool. All right, good. So it looks like we're understanding this negative feedback. And do you guys you remember we already talked about shivering and sweating? We talked about that. It was last semester. We talked about that in the integumentary system with homeostasis, where you did that little activity about the person running. Remember, you were making them work out and exercise and dehydrate and all that. So we've already kind of looked at this, but we just haven't, defined it in these terms. So note that obviously the whole body is related, and that's why some of these things look familiar. So what I'm going to do, guys, is I'm going to pick up where I left off last time and tell you some more about the endocrine system today. So we left off talking about largest view. Okay, so I'm trying to move my slide. Okay, so these are all the hormones of the endocrine system. You're not going to have to know all of them. Like I told you guys, we're really only going to focus on the main glands that were covered in this chapter in particular, and things that we saw in the crash course video. So I'm not going to cover all of them. I'm going to cover more so the important ones to you as teenagers. Okay, so these are the 10 glands that we've been looking at, and they were mentioned in the crash course video. If you weren't here with us on Monday we did a little group activity where one person shared their screen and we went around and we labeled where the glands were. Okay, so now that we know where they are, what they're called, we need to talk about what it is that they do. Okay, so we're going to start with the pituitary and hypothalamus and then work our way down to the gonads. Okay, and like I said, if you've already read this in chapter 7 and you're ready for the quiz, which is just a summary of all this, you can just message me and I'll turn on that quiz for you. Okay, so we'll start with the pituitary gland and we're going to see how far we get today, and then I'll just wrap up the rest of this on Friday. Okay, so we'll start with the pituitary, and the pituitary gland, as you remember in the video, they call it the master gland, and it's called the master gland for one because it's really what determines what all the other glands in your body do. So it's kind of like the control center for all other glands. There are two parts of the pituitary gland, what we call the posterior and the anterior, which I'll show you in a second. The posterior is really the more important one because that's the one that produces all the hormones. It's found near the hypothalamus, so we kind of refer to that region as the, here, I'll show it to you here, as the hypothalamus pituitary complex because they are found together. So here's your brain, and this little nugget here at the base of our brain, this is called the pituitary. And like I said, there are two regions, the posterior, which is the purple one. This is the one that produces all those hormones for us. And again, this is the control center for the entire endocrine system. That's why we call it the master gland. And then the hypothalamus is right on top of it. Okay, so I'll go back so you can see. So we have the pituitary gland and we have the hypothalamus, and both of these two work together in this hypothalamus pituitary complex to control pretty much everything that happens in our body. Okay, And it releases a lot of hormones. It makes a lot of hormones. And like I said, I'm not going to cover every single hormone with you, but there are 3 in particular that we should focus on. Right now, as teenagers, there is a hormone that you are producing in your pituitary gland called the growth hormone. And this is something that as teenagers, you're probably aware of. You know that you're not just growing just because. Your body's being stimulated to grow. It's triggered by sexual development, by your age. And the name of the hormone that causes you to grow muscle, to get taller, et cetera, basically go through those physical changes, not sexual changes, but physical changes associated with growth, is this hormone called growth hormone. Okay, and this is the hormone that, and I'll circle it here for you so you can see, this is the hormone that is causing you to grow. So if you have ever been told, oh, you're really short for your age or you're really tall for your age, it's not like testosterone necessarily that is the reason why you're getting taller, right? Because we're going to talk about testosterone in males and females later, but the name of the hormone that just causes physical growth is called growth hormone. Have you guys ever heard of diseases like gigantism or dwarfism? Do you guys know what those are?
Yes.
So an increase or like too much of this growth hormone is one of the reasons why people experience what we call gigantism, or being a giant. And too little of this hormone is one of the reasons. And there's lots of different types of dwarfism disorders, but having too little of a hormone, growth hormone, can also cause a person to be extremely short. Another hormone that I would like you to know, we'll just abbreviate it as ADH, but it stands for antidiuretic hormone. We actually already talked about this. We talked about this in the excretory or the urinary system. And this is what allows you to store water in your kidneys. So ADH is the hormone responsible for you basically not being dehydrated all the time. So it is a very, very important hormone produced by the pituitary gland. And the one that Angel was referring to as far as the menstrual cycle, that hormone is called oxytocin. And this is one of the hormones that not necessarily just during the menstrual cycle, but it is responsible for a lot of female changes actually during childbirth or during pregnancy. In the example of the baby suckling on the nipple, that was the hormone that stimulated the release of milk. It's also the hormone, as you can see here, that stimulates the uterus to contract. So the more the baby is pushing, the more this hormone causes the uterine to actually expand. So would that be negative or positive feedback then? Negative or positive?
Is it positive?
It would be positive. Very good, Daisy. Okay, so let me erase my stuff here. Okay, so the pituitary gland, like I said, has a lot of hormones, but I'm only going to ask that you know those 3: growth hormone, ADH, and oxytocin. The pineal gland right now is a really important endocrine gland that might be a little thrown off because of our erratic sleep schedule. Raise your hand here if you're still waking up at the same time, like before the school is closed. Like, who's still waking up at the same time? Give me thumbs up if you're waking up at the same time. Give me thumbs up if you're waking up later. Okay, so it looks like, well, yeah, all of you. Yeah, that's what I would imagine. I'm guilty too. I wake up a little bit later too. But get this, guys. There is a hormone produced by the pineal gland, And that hormone, you've probably heard of it. It's called melatonin. Melatonin is the hormone that our pineal gland releases that dictates or regulates our sleep cycle. And our sleep cycle, you've probably heard of it. It's called the circadian rhythm. If you don't know that word, that's okay. I'm just putting it there for fun. But your sleep cycle is actually regulated by this hormone. And so if you're staying up late, gaming all the time, waking up even later, you're throwing your body in an imbalance. And physiologically, we are not bats. We're not meant to be up all night and waking up late. Like our internal physiological clocks we're diurnal. We're creatures of the day. So just be aware that there is something you can do to kind of get your sleep cycle back in regular, mode. And they actually sell melatonin. You've probably seen these at pharmacies. They sell it. It's like a man-made version of melatonin, and it helps you get to sleep. And you've also probably heard of like teas that do the same thing. They have something very similar to melatonin in them that kind of puts you into that regular physiological mood of your sleep cycle. Another really, really important hormone that the pineal gland produces is called serotonin. And in class, when we were working on our health project, which seems like so long ago, I think it was Abel's. I think it was Abel. There was some other groups that might have mentioned serotonin in the project, but serotonin is what we call like the feel-good hormone. It's what causes that feeling of joy in us. Not all of us are probably experiencing that now, but know that the pineal gland is responsible for that hormone there. So really, really important hormones in the pineal gland. And here is a picture of the pineal gland. So again, here's the pituitary. It's that little nugget at the base of your brain. It sticks out. It's very, very obvious. The pineal, you can't see it from the outside. You would actually have to do a trans-sectional cut like this of the brain to be able to see inside of it. And it's this little circle here at the base of the cerebellum. Okay, so that's the pineal. The adrenal glands, and I'm going to pause here for a second. The adrenal glands, you probably remember it from the video. There's two of them, right? There's one on top of each kidney, as you can see here. And the kidneys, if you recall, they have different layers. And I know we looked at the kidneys already in a previous chapter, so I won't talk about them too much, but I'll just refresh your memory that the major regions of the kidney, there's regions of the adrenal glands as well, and they're called the adrenal cortex and the adrenal medulla. And each one of those produces its own hormone. I'm not going to ask you to know all the hormones. I'm just going to ask you to really focus on like two, okay? So here is a picture of the adrenal gland. So the gray on the bottom, that's the kidney. The adrenal gland kind of looks like the beanie that sits on top of the kidney itself. And if you do a cross section of the adrenal gland, they're actually divided into these zones. Okay, so there's this top zone, there's this second zone, this third zone, and then this very, very bottom zone that we call the medulla, which is really just like the kidney itself, okay? So in the adrenal medulla, there is a hormone that you are very, very familiar with called epinephrine. And epinephrine is the hormone that was mentioned in the video. It's also the hormone that we call adrenaline. That's another reason why it's produced in the adrenal medulla. So think of it like adrenaline. And epinephrine or adrenaline is that hormone that you experience like in times of stress. That's why we call it the stress hormone. You experience it like if you're running away from an accident, if you're running away from a fire, if you're going down a roller coaster, if you're asking someone for a date or whatever. Epinephrine or adrenaline is that feeling that we call the fight or flight response. Fight as in like, quick react. flight as in like, I'm out of here, right? So this hormone, epinephrine, also norepinephrine is like its counterpart, but these set of hormones produced in the adrenal glands are primarily responsible for that response of fighting or flighting or reacting. That's why we call it the stress hormone. Okay. Let me erase this. Any questions so far? I've covered 3 glands so far. Any questions so far? Okay. So the other hormone that I would like you to also note, I circled it here. So epinephrine or norepinephrine are responsible for the fight or flight response, but you've also probably heard of cortisol. Cortisol is similar to epinephrine, and what it does is it increases your blood glucose levels. During like like if you're an athlete, I know a lot of you in here are athletes, so if you're an athlete or if you're going down a roller coaster or if you're like going to get into a fight or whatever, this hormone also increases. Can anyone think of any reasons why, like for example, an athlete, let's see, where my athletes at? Who plays sports in here? Savannah. Okay, Savannah, I know you're an athlete. Savannah, can you think of any reasons why during a game you would want an increase in this hormone cortisol? Look at what it does.
I mean, it's something that like you need in order to like keep playing. So like it keeps you like motivated just to like,
True,
mean,
true, but look
yeah.
at what it does specifically. You're right, Savannah, but look at what it does specifically. How would that accomplish what you're saying? Because you're kind of right, but look at what I underlined. How would that help you do that?
To be honest, I have no idea.
Okay, do you remember what glucose is?
The it's the sugar, right?
It's
So
sugar. It's
yeah.
sugar, exactly. So you just told us that for an athlete, we need this hormone to be able to keep going in a game. So how would cortisol do that then, do you think?
I mean,
You just said, right? It's sugar. So how would that help us do what you just said?
so glucose is a sugar, but then it's also an important like energy source, isn't it? So like it keeps you, yeah.
Exactly, because it's energy, it's energy, right?
Yeah.
So for athletes or for anyone who's experiencing like a stressful situation, adrenaline is released, which is what epinephrine is, to help us, react. That's what fight or flight is. But the energy, like you just said, Savannah, the energy, the sugar, glucose, is what gives us that actual boost in our muscles to do that stuff. So have you guys ever heard of like, they're like old like myths where they say like, oh, this old lady was able to lift a car off of a baby or whatever, it's not necessarily like that she's a bodybuilder or anything like that. It's because these two hormones, cortisol and epinephrine, during stressful situations, they actually can skyrocket. And so you hear cases of people doing amazing things because during that time, these hormones were elevated. Okay? So very good. Let me erase that. All right. And I think I'm going to pause right after this next one. I'm going to just jump to the pancreas real quick because this is kind of where I started the class, and I'll end it here. So at the beginning of class, for those of you just joining us late, you can rewatch what we talked about at the beginning. But at the beginning of class, I showed everyone a quick little video about negative feedback loops. And Daisy gave us an example from the crash course video that we saw on 2 hormones that the pancreas releases called insulin and glucagon. Okay, so what I'm going to have you guys do, I'm going to end class like this rather than me talking all day. I'm going to put you guys into groups. And in your groups, what I want you guys to do is you're going to, just one person, like last time, share your screen with us, and I want you all to draw me a model of what negative feedback loops look like in our body. It can be any example. You can do the example that Daisy gave you. You can do something similar to what you saw in the video at the beginning of class, but any model, because negative feedback loops will be covered in the quiz for this module. So I want to make sure that you know what you're talking about. So I'm going to put you guys into groups, and I'm going to ask that just one person share their screen, turn on your whiteboard so you can draw, and I need each group to come up with a model of how negative feedback loops work. Thumbs up if you get me. All right, cool. So here we go. So we'll make small groups today. We'll do 3 groups. Okay, so you're going to get an invite from me. Please, one person from each group, turn on your whiteboard, and I want to see models, okay? All right, so who's going to share their whiteboard screen with us?
How do you do that?
At the bottom, you have the share options, and and one of the shares should say like whiteboard.
Oh, okay.
There it is. Thank you, Myrtle. So go ahead and draw on theirs, Myrtle, so they can see how you're doing that. Just go ahead and draw anything, a line, a heart, whatever. There you go. Okay, perfect. So the rest of you guys, Angel and Savannah, you can actually also sketch on Myrtle's page. You should have an annotate, like a little pencil feature. Go ahead and do that for me, please, guys. There you go. You see how that works?
Yeah.
Okay, so I'm gonna come back, but please, if you could, the 3 of you, come up with some sort of a model that explains how negative feedbacks work. And it can be for any hormone that we've talked about. Okay?
Okay.
Okay, I'll be back, guys. Thank you. All right, cool. So who's drawing? Daisy? All right. The other members in this group, let's see, Anna and Brianna. Okay, Anna and Brianna, you guys know that you can sketch on Daisy's whiteboard too, right?
Yeah.
Okay. You know how to do that?
Yeah.
Okay, perfect. Just checking. Okay, so any model, it can be the insulin one if you want, Daisy, since I know you know that one. But please make sure everyone is contributing, Daisy, okay? Not just,
Oh, yeah.
I know you know how to do it already, okay? Okay, I'll be back. Thank you, guys. All right, cool. So who's drawing? Haley, okay. Let's see, it's Scarlett too. Okay, Scarlett, you know how to draw on Haley's board, right?
Yeah.
Okay, so do you guys understand what I'm asking you to do?
Yes.
Yeah, but
What am I asking you to do?
the negative counteracting.
Yeah, so draw me any example, Scarlett, of a negative feedback loop, which is like you said, it's something that counteracts something else. So it can be anything. It doesn't even have to be hormones, just some sort of a model, a representation, but with pictures, not words, of how we just saw in that video, how something counteracts something like you just said, Scarlett, or even an example from the crash course video or covered in the chapter. Does that make sense?
Yeah.
Okay, so I'll be back in about 10 minutes, okay? Thank you, guys.
I think. And then the pancreas also releases glucagon. I forgot what it's called, but it goes into the liver and it cycles. So like kinda, I think, I don't know how to pronounce. Yeah. And then
Do you say to draw it or just cycle?
I think the cycle.
Okay.
Or I don't know. That arrow.
I'm in the iPad. It's so ugly.
I'm on my phone, no worries.
Oh my god. Okay, no, whatever.
What are you gonna put there? That's gonna go to the pancreas, right?
Yeah. Dude. What the heck, man? So
Yes.
ugly.
Okay, wait. Oh, that's too big. Oh my god, what the fuck?
What the? Ew.
So I see a lot of words here, guys. I asked for a model, so can you tell me like what you're trying to explain to me?
Um, hold up.
Is that a
Excuse me.
pancreas?
Yes. I can't draw.
Okay, close enough. But tell me what's happening here, though.
We're talking about how like the pancreas releases this insulin. I
Mhm.
think that's what it's called.
Yeah, you read it.
And and it releases into the well, we're gonna do the liver, that it goes into the liver, and it like creates glucose, and it like helps rise and lower the blood sugar. Like it like what's it called? It like it like balances it out. And
Okay.
we're also gonna put well, it also helps like the pancreas and all that too.
Okay. You're on the right track. I'm just walking around checking. Okay, keep going.
Hmm.
What is this?
Is that the liver?
Oh, cool.
Yeah,
Cool. What do we have here, guys?
the sweating.
Okay, and so how is that an example of negative feedback?
So like once like the body like senses the heat, the hypothalamus is like telling the body, hey, like we need to cool down, I guess. And then so that signal is like sent, and so like they start sweating,
And what does sweating actually do then?
cools down the body.
Cools down.
Perfect. Good. See, easy enough example, but it's like a mirror of exactly what Daisy told us, right? We may not be talking insulin here, but we're still doing something to counteract some other effect, right? Good job. Do me a favor, guys. When you're done with this drawing, you can save these drawings, right?
No.
Yeah, you have an option if you go to it's somewhere on your screen. On my screen, under View Options, I have an option to say. If you go to your share screen options, go ahead and click on that. You don't have something that says Save. You should.
I can see it.
Okay. Do me a favor. Was that Anna that said that?
Daisy.
No.
Oh, it was Daisy.
Daisy.
Okay, Daisy. When you're done, can you please save this picture? Because I want everyone to share their pictures at the end, okay? Okay, thank you guys. No, good job. Yeah, you got it. You're pretty much done. So just put your finish labeling it and then save this for me so we can share it out, okay? Thank you guys. Okay, so explain to me what's happening here.
So basically, like, since there's a lot of predators, since like the predators like outnumber the prey, each time a predator attacks the prey, there's less prey. That makes sense.
Okay, and so how is that negative feedback then?
Because
the number of preys continues to go down.
Because the number of predators goes up.
yes.
Okay, yeah, good. So you see, you were able to explain something really complicated like insulin, but using an example that you're more comfortable with. Okay, so do me a favor, Haley. Did you draw this, or did Scarlett draw this, or you both drew it?
Mm, I did.
Okay, so do me a favor. You have an option on your page, Haley, to save this image. Can you save this, please? Because I want to end our groups now, and I wanted every group to share out what they came up with, because everyone came up with something different, and yours is like completely different than everyone's, but it kind of makes sense. So can you save this for us, please, Haley? And then I'm going to have everyone talk about their example. Okay.
Okay.
All right. Thanks, guys. All right. So all right, so I'm breaking up all the groups now, and I went around to all groups, and again, the task was for you to draw your own model or example of how a negative feedback works. So I went to all three, and actually all three groups had something completely different. So that's good. So what I'm going to ask is if one representative from each group can share their screen. I know we only have 4 minutes. If you can just pop up your picture. So I think the people that drew were Haley, Daisy, and Myrtle, right? So can one of you at a time please share your screen with us and walk us through how that's negative feedback? Who would like to start? Haley, Daisy, or Myrtle?
I'll go first.
Thank you, Daisy. All right, perfect. Okay, so explain to us how this is negative feedback.
Okay, so we drew a person sweating, and so basically the person is like feeling the like heat from the sun, and it's like overheating. So then the hypothalamus senses this heat, and then like tells the body, hey, like it's getting too hot, we need to cool down. And so the rest of the body like receives the signal, and so like the glands produce sweat, and so the sweat would cool down the body.
Perfect, perfect. Does that make sense, guys?
Yes.
Does that make sense? Perfect. Yeah, and that was a really good example. It wasn't, insulin, but in the example of the variable that caused the change, what was the variable here that caused the change? What was the variable that caused all this to happen in the first place, guys?
The heat?
The heat. Exactly. Very good. Okay, Daisy, can you stop sharing your screen? And
Yeah.
either Haley or Myrtle, can you put up your example? We have 2 minutes left, so we'll if we don't get to both, that's okay. But can we have at least one more up? And then we're going to wrap up here. So Haley or Myrtle, someone please put up your picture.
I didn't get to screenshot it.
Oh, you didn't screen. Oh, damn. I'm sorry. Haley, did you get a chance to save yours?
Yeah.
Okay, can we see yours real quick? I'm sorry, Myrtle. I think I might have ended your group too quick, but I saw yours, Myrtle. You guys were on the right track. You were just putting it in words, which is fine. But let's look at Haley's and see if we can figure out Haley's together, okay? Sorry about that, Myrtle. Okay, good. So Haley, explain to us, first of all, what is this? And then tell us why it's a negative feedback loop.
Okay, so it's just like, I guess, like a cycle, like nature-ish, I guess. And then like what I drew was like the number of predators increases while the number of prey decreases. And yeah, the predators cause the changes because since they attack the prey, I guess, they decrease and then the predators just increase.
Yeah, yeah. So a very different example that Haley came up with. This is more like, you know, an ecosystem type of negative feedback loop. But is this correct? Is this a negative feedback loop? How about Myrtle's group? Since, you know, my bad, I didn't get to see your, I mean, I saw it, but I didn't get to show the class. So Myrtle's group, I think that was Angel also. Is this negative feedback?
I think it's a positive
Why do you say that?
because like it's I don't know how to explain it, but like the number of predators is like increasing because of the number of preys. Like I don't know how to explain it.
I think I know what you mean, Angel, but let me tell you why this is negative feedback. Okay, here's the easiest way to think about it. Okay, we talked about in the respiratory system, I told you, like, if something goes up, something else goes down. Remember, we said pressure and volume. Do you guys remember that? So it's similar to this. What Haley is saying is, April, can you exit? I'm finishing up this class. I'll be right with you. Okay. What Haley is saying is, if predators go up, what happens to the number of prey? Up or down? If predators go up,
Down.
they go down. So that inverse relationship, guys, that's pretty much what a negative feedback is. So Haley's example is very different than what we were talking about, but it's actually correct. Okay. So very good, guys. I'm going to go ahead and end this class now because I see some of my other students are coming in from period 4. So Victor, can you exit this group? I'm gonna start you guys like right now, okay? So I'm gonna go ahead and end the class here, guys. And again, if you want to go ahead and start the rest of the modules, you can go ahead and do so. Just message me if you want me to turn on the quiz. But other than that, I'm gonna record this and put it on updates for you. And message me if you have any questions, okay? Bye, guys. See you Friday.
Bye.
Um,